Hello, my name is Hiro Maehara. I'm a solution planner and application engineer at Keysight. There is an increasing demand of secured connectivity and sensing needs in many variety of applications. For those use cases, we see the RF system employs the high-speed data converter together with RF front end. That makes RF engineers a great challenge for characterizing their device under test. Typical example here, which using for the demonstration, is the transceiver IC. Recent transceiver IC has much higher sampling rate, wider input bandwidth, digitizing direct RF signal into the digital data. When designers want to characterize RF performance, they have to deal with the digital data, which no longer let them use the traditional RF to RF test instrument to measure the RF performance. Our solution demonstrating here is wideband digital transceiver test solution utilize existing PNA network analyzer using internal signal generator to generate RF stimulus for the receiver test. And the device under test digitize the RF signal and create the IQ waveform. We grab those IQ waveform and then process into the network analyzer. This allows us to compare the input waveform and output waveform to compute the frequency response. Measurement example of the receiver side showing on the left side. Top windows showing the receiver input and the receiver output. Receiver input is RF signal. The receiver output is the digital signal. We compare those two signals and measure the gain versus frequencies, as well as delay deviations and the phase deviation relative to linear phase response. This particular device also has a transmitter channels. For transmitter measurements, we generate digital IQ data, download the IQ data into the device, and the device output the RF signal. We measure that output signal with the PNA network analyzers. The result is showing here on the right side. Again, we measure the gain versus frequency, delay deviation, and then phase deviation as well. The other measurement that we can make is the relative response between two receiver inputs and two receiver output. With the same setup, we can easily compare the two signal output from the transmitters. Those signals we measured by two of the test ports of the network analyzer and compare the vector response. That will tell you how much gain and phase differences by the channel by channel. This is very crucial to understand the channel deviation when you are to make the phased array antenna like multi-port systems. Same measurement can be done for the multiple receiver channels. In that case, we generate RF signal split into the two different receiver inputs, and two digitizer digitize those two RF signals at the same time, and we capture the digital data and process to compare the differences, compare two RF input and find the differences. So here is an example of the response of the two different receiver channels, and then the difference between the two physical receiver channels in magnitude and then phase. This whole setup was not being available for RF and test engineer to understand their RF system performances once their RF front end has been integrated with the digital baseband. This new digital wideband test signal allow the cross-domain RF and the digital stimulus response system, which gives you essential information to characterize RF performance characteristic of such integrated devices. Thank you for watching. If you need more information, please contact Keysight representative.